In levels 1 and 2, we talked about the product property and we talked about the power property. And in the product property, we had to add the exponents. But within the product or the power property, we had to multiply those exponents. Now we did those in isolation, so it was either the product property or it was the power property. But let's see how those work together, and we're going to add in some coefficients. So here's an example of our product property with some coefficients. And we want to ask ourselves, well, how did they get these numbers? How did the 3 and the 4 become 12? Well, they were multiplied together. How did the 2 and the 5 become 7? They were added together. Now, we know from our product property that when I have a base multiplied by another base, I have to add the exponents. And the coefficients, in order to get 3 and 4 to make 12, they had to multiply those coefficients. And let's think about why that is. Okay? We'll see in a few moments that these coefficients do not follow the product property. The coefficients have to act just as they've acted since you learned how to multiply. They will follow 3 times 4 and equal 12. It's only the exponents that are going to be applied with the product property. Let's see if the same holds true for our power property. So in the power property, we have to ask ourselves, how did 2 raised to the third power become 8? And how did the 4 and the 3 become 12? Well, as a reminder, when we have those exponents that are raised to another exponent, we have to multiply those exponents. And the coefficients are going to do just what they've always been told to do, exactly as they appear. The coefficient is going to be raised to the power. Two to the third power gave us 8. So let's kind of put this all together here in some statements that we can follow. So in those examples, we saw that those coefficients did not get the special treatment that our exponents got. If we are given a multiplication problem, we have to multiply the coefficients just like we always have, and the exponents will get added. So we will multiply the coefficients and we'll add the exponents. And if we're given a problem where we have to take something to a power, we're going to raise the coefficients to the power and we'll multiply the exponents. So the only things that get special treatment are exponents. Let's turn the page here and do a couple of examples. So to simplify these expressions, we have to first identify what's going on in the problem. We have 5x to the negative 6 times 2x to the fourth, and it's also raised to the third power. And we need to kind of follow those order of operations just like we've been taught. Just as a reminder, our order of operations are written here, where we're dealing with parentheses first. There's nothing inside these parentheses I can do. Then the next is the exponents. So that means I have to deal with the power raised to a power first. And that would make sense even if we were dealing with our special cases here, our special treatment for our exponents. We would multiply before we added exponents. So here, I need to make sure that something to the third power has been applied to everything inside. That includes this 2. So the 5x to the negative 6th will remain on its own, and everything inside here is going to be raised to the third power. That means that 2 will be raised to the third power, and x to the 4th is going to be raised to the third power. Now we know that 2 raised to the third power is equal to 8. And x to the 4th raised to the third power, I multiply these exponents, so I get x to the 12th. And as we saw in the previous page, the coefficients are not going to get special treatment. We're going to multiply those coefficients together. 5 times 8 gives me 40. And we're going to add these exponents together. Negative 6 plus 12 gives me positive 6. Take a look at number 2. So I have to deal with something raised to a power first before I can move across this multiplication. So the 12y to the negative 3 is just going to move down. And I have 15 that's going to be raised to the 0 power. And I have y to the 7th raised to the 0 power. So 12y to the negative 3rd. And I have 15 raised to the 0 power. We know that that's really just 1. And y to the 7th raised to the 0 power. We know that that is just 1. You could also think to yourself, 7 times 0, that gives me 0. And I know that that will simplify down to 1. So I have this whole business here, times 1 times 1, which is not going to change anything. And I'm left with this 12y to the negative 3rd. We also know that if we're asked to simplify, our answer cannot have any kind of negative exponent in it. So that y to the negative 3rd is going to move down to the denominator. And the 12 will stay right where it's at. So there's my final answer. Number 3. We have to deal with the power property first. So the 3z to the 5th is just going to move down. And the 2 will go with the 9 to give us 9 squared. And the z to the 8th will also, z to the negative 8th, will also be raised to the second power. So 3z is going to move down once more. And we know that 9 to the second power, you can do that in your calculator. I know that your calculator will look a little bit different than mine, but you can always raise something to a power by locating this button right here, which is the same button that you might see when you press Shift and 6 on your keyboard. So it would look something like this on your calculator. Of course, your calculator would not be the graphing calculator, but it will look something like this if we were trying to raise it to a power. 9, and then press that caret button and raise whatever power you're looking for. But 9 squared is 81. And then I'm going to multiply these exponents here. Z to the negative 8 times negative 2 gives me z to the negative 16. Now it's time for me to go ahead and multiply my coefficients. So we have 81 times 3, which gives me 243. And z to the 5th times z to the negative 16 means I'm adding the exponents, which gives me z to the negative 11. And we know that we are not allowed to leave a negative exponent in my answer. So that z to the negative 11 has to move to the bottom. In this level 3, as you're seeing, the problems get a little bit longer, a little bit more complicated, but they're still following the same rules that you see in level 1 and level 2. Number 4. We have to deal with our power property first. So 2w to the negative 20 is going to hang out first. And then we need to take the fourth power and apply it to the 3 and multiply our exponents for the w. So we'll have w to the 5th raised to the 4th power here. 2w to the negative 20 is still going to move down. We'll type into our calculator 3 to the 4th power and we'll get 81. And if you forget how to type it into your calculator, you know that 3 to the 4th power is really 3 times 3 times 3 times 3. So you can always get an answer there as well. Multiplying our exponents here will give me w to the 20th. In our next step, we'll multiply our coefficients to give us 162. And we will add our exponents. Negative 20 plus 20 gives me w to the 0. We know from our last standard that anything raised to the 0 power is just 1. So my answer is 162.